Now we're going to look at some examples which use bearings. The first one is the road from town A runs due west for 14 kilometres to town B. A television mast is located south of B at a distance of 23 kilometres. The first thing to know is, what does due west mean? And due west means that it goes directly in a straight line from east to west. So it's due west means in a straight line, directly west. So we've got to draw a diagram and calculate the distance of the mast from the centre of the town. So we're going from somewhere west, so we're going to go in that direction. So let's start town A. Okay, goes west to town B for 14 kilometres. Then we go south for 23 kilometres, and that's where the TV mast is. Let's call that M. We'll always be interested in doing triangles. Okay, so we'll join it back up. Because we've gone from west to south, it's 90 degrees, so drawing your 90-degree angle. We're to calculate the distance of the mast from the centre of town A. So here we're using Pythagoras' theorem in order to work out this length here, which is C. So C squared is 14 squared plus 23 squared, which gives us 725. Remember, always square it, root your answer. So C is 26.93 kilometres. So nothing new there apart from being able to draw your diagram out. Now we've got to find the bearing of the mast from the centre of town, and that should really say centre of town A. That means we're starting at A because we're going from town A, so we'll draw in north, and we want the bearing of the mast, so we're going to go clockwise round to where we meet the line that joins the mast. In order for us to do that, we'll always need to be finding an angle in a triangle because they're the angles we can find. So the angle in a triangle that we're going to be interested in is this one here. So if we can find that angle, we'll call that theta. And an issue with bearings questions are that there's several different ways of doing these. I'm going to find theta using a right angle triangle, and then I'm going to take that away from 270 degrees to get my bearing. We'll look at other ways we can do that in a second. So to find theta, we're using right angle trigonometry. We know opposite and adjacent, so tan theta is opposite, which is 23, over adjacent, which is 14. Remember, to find an angle you do inverse tan, or you can use your E activity on your calculator. So theta is 58.67 degrees. That isn't our bearing yet, we need to work out our bearing. The quickest way to work out a bearing would be to go 270 degrees, take away the angle theta, because this whole angle is 270, and we're not going the whole way, we're doing theta less. So our bearing would be 270 degrees, take 58.67, which gives us 211.33 degrees, or if to the nearest degree, 211 degrees true. Other ways you could do it would be to go, well, that's 180, this angle here would be 90 minus 58.67, and then add that on to 180. This next example is a really common type of question that you might come across in terms of bearings. So we've got a boat sails from point A on a bearing of 56 degrees for 1200 metres to point B, then changes track on a bearing of 156 degrees for 2000 metres to finish at point C. So start off, draw in point A. So there's A. We go on a bearing of 56 degrees. Remember, drawing the north line, 56 degrees will be up here to point B. and that's 1200 metres. Always label as you go, you find that's a little bit easier. That is 56 degrees. Drawing our north line from B, and draw in our new line to C, which will be 156 degrees for 2000 metres. So 2000 metres and 156 degrees. That then finishes at point C, and draw a line back to A. First thing we want to do is find the distance from A to C, so this distance here, which we will call B because it's opposite angle B. Now, in order to find length B, we're going to need to add in an angle somewhere in our triangle, one of these ones. Because we've already been given two sides, okay, if we find the angle in between them, this one, we would be able to use the cosine rule. So this is the trick with using bearings. We've got to somehow use the bearings that we know to find this angle here. And the way we can do that is use the bearings we're given and use the fact we've got the north-south line. Because this is 180 degrees, and we know this little bit here is 156 degrees, from the BC line to the north-south line is 180, take away 56. So this angle here is 180 minus 156, which is 24 degrees. We also need to then work out this angle here, and we can do this using alternate angles because two north lines are parallel. These two make a Z, so they're the same. So this angle is 56 degrees. So add 56 and 24 to get our angle at B, which is 80 degrees. And that is the key step, is that you'll probably have to do something like that to find an angle. So now we know our angle, we can use the cosine rule to work out B. So the cosine rule is B squared equals 1200 squared plus 2000 squared, take away 2 times 1200 times 2000 cos 80 degrees. If you did it by hand, that gives us 4,606,488.747. Remember, that's B squared, so we have to square root our answer. So B is the square root of 4,606,488.747, which is 2,146.27 metres. Now we have to find the bearing of C from A. Remember, from A means we are starting at A and we're going to C. So we want to work out that bearing there. Okay. If we can work out this angle, so the angle A, we then add it on to 56 degrees to give us the whole bearing. So what we're asked to do now really is find angle A. To find angle A, we know an angle and an opposite one, and we know another length, so we're going to use the sine rule. And we're going to say sine A over 2000 equals, we know sine of 80, and that's opposite what we've just found out, so 2146.27. If this was all one part of the question, you would need to use the exact answer. Because we've already worked this out in A, we can actually use the rounded answer now. So we rearrange that to get sine A equals 2000 times sine 80 over 2146.27. To get the angle A, remember do inverse sine of all of this. You could have alternatively used your calculator. To get A is 66.59 degrees. That's just the angle at A, so this angle here is 66.59. So our new bearing is going to be 66.959 plus 56 degrees. So 66.59 plus 56, and so our bearing is 122.59 or 123 degrees. True.